All right, I want to go ahead and talk about the next page of the review. ABCD is a rhombus if EB is equal to 9. So here's EB, that's 9, and AB is 15. And the measure angle ABD is right here. So this whole thing is, no, actually it says ABD. So we're talking about this angle here. That is 55 degrees. Okay, great. So this is a rhombus. We can assume that this is a rhombus. Diagonals of a rhombus are perpendicular. So if I have my diagonals here, I can draw a square, and then I can go ahead and redraw that triangle that you see. So you see that triangle there? So then that's going to be 9, 15. And my goal here is to figure out what AE is. This is AE. We're just going to go ahead and put a question mark. Okay. So this is Pythagorean Theorem. So I have to do a squared plus b squared equals c squared. And then I'm going to plug my values in. I have... So we know that the longest side of the triangle is 15 because the hypotenuse, which is our C, is across from the 90-degree angle, right? So I can go ahead and plug C, or replace the C with 15. And then everything else, you can put whatever you want. You can let this be A or B. It doesn't matter. It won't change anything. So question mark squared plus 9 squared. If I subtract both sides by 9 squared, I get question mark squared equals 15 squared minus 9 squared. And then I take the square root because I want to get the question mark by itself, right? The square will go away once I take the square root on both sides. Now, if I were to, put it in the calculator, then I'm going to get the value AE is 12. Okay? Now, let's go ahead and take a look at 35. So BDA. BDA. So, since this is a rhombus, the diagonals actually split this whole angle into two congruent parts, right? So this angle here is 55, and this angle here is also 55. And since a rhombus is a parallelogram, opposite angles are going to be congruent. So whatever 55 times 2 is, right? Whatever that is going to be the same thing as here. So, but that means that we have to split that whole angle into two congruent parts. So this here is 55, and this here is also 55. So we can put 55 here and 55 there. So what is BDA? Well, BDA is 55 degrees. Okay? And also, you can also say, since a rhombus is a parallelogram, and this is my transversal, if this is 55, then this is 55, right? And then you can go ahead and say, because of the diagonals, split the angles into two congruent parts. If this is 55, then that's 55 as well. Okay? Hopefully that makes sense. All right, let's take a look at this one. This is a kite. And I wish they, made that or stated that somewhere, but this is a kite over here. Now with the kite, the diagonals are perpendicular, so I can go ahead and draw a square there. So if I redraw that triangle that you see, I can go ahead and say that, well, that's 12 and this is 15. I'm trying to figure out what GH is. So I'm going to put a question mark. And again, this is a Pythagorean Theorem problem because this is a right triangle. So let's go ahead and first write the equation, the Pythagorean Theorem, which states a squared plus b squared is equal to c squared. And, well, we need to figure out, or we need to identify what C is. Well, C, again, is the longest side of the triangle. It is across from the 90-degree angle. So the question mark, I'm going to replace C with the question mark. So question mark squared. And then A and B can be whatever you want. It doesn't change anything. 12 squared plus 15 squared is equal to my question mark squared. Okay? So the question mark squared, I can take the square root, because I want the question mark by itself. So if I put this, well, first of all, this is going to go away. That's going to be a question mark. Stop doing that. What the heck? If I put a question mark there. So take the square root of 12 squared plus 15 squared. That is going to give you 19.2. Okay, so GH is 19.2. Now, I'm going to go ahead and move on to 42. Measure angle Z is right here. And this is an isosceles trapezoid because, one, it is a trapezoid because it has one pair of parallel sides, and then the legs are going to be congruent because they're both 23. So this is an isosceles trapezoid. So the base angles, so this angle here and this angle here are congruent, and then we're going to go ahead and figure out that angle here and that angle there too. So my goal here is to figure out measure angle Z, yeah? So if this is 112, then this is also 112 as well, okay? And there's two ways that you can do it. You can solve it algebraically, or you can just be lazy. I'm going to solve it algebraically. So I don't even know what this variable is. I can call that x. I can call that x, right? And because this is a quadrilateral, remember quadrilateral means 4 sides. So 1, 2, 3, 4. And I'm dealing with just angles here, right? I'm trying to solve for what this variable is, or what angle Z is. So this is going to be equal to 360. So the sum interior angles of a quadrilateral is 360 degrees, right? So I can say, okay, let's go ahead and add all these up. I have x plus x, which is going to be 2x. And then I have this 112 plus 112. That's going to be plus 224. Okay. So then I'm going to subtract both sides by 224. I'm going to get 2x is equal to 136. And then if I divide both sides by x, or sorry, not x, 2, I get x is equal to 68 degrees. Okay, so what does that mean? So I can go ahead and replace this x with 68 and this x with 68, and I can go ahead and verify with my calculator. Well, 112 plus 112, that's 224, and then plus 68 plus 68, that's going to be 360. Okay, so that is going to check out. That's going to work out. So what does this mean? Well, measure angle Z is going to be 68 degrees. Okay, and that's all we're trying to figure out. And this is also 68 degrees as well. Okay, all right. Let's go ahead and take a look at this one. It says find the sum of the measures of the interior angles of each convex polygon. Now, this is a repeat of certain problems that we did on the first page, or the types of problems that we did before. We're going to go ahead and ignore convex, the meaning of convex. I just care about what this means. Find the sum of the measures of the interior angles. Now, again, that formula, you need to know this. It's going to be n minus 2 quantity times 180. Okay, so remember, n represents the number of sides. N represents number of sides. And you need to know what a hexagon is. A hexagon, again, that's a 6-sided figure. So n is equal to 6. If I replace this n with the 6, well, this is going to be 6 minus 2 times 180. So that's 4 times 180, which is 720 degrees. So that means that this hexagon, the total, or the sum of the measure of the interior angles of a hexagon is 720 degrees. Okay, so let's go ahead and take a look at the 2. It's already given 16, right? N is equal to 16. So I do 16 minus 2 times 180. Or you don't have to necessarily memorize this for me, actually. Just remember, you just got to think triangles, right? If you draw a 6-sided or 16-gon and then, you know, connect vertex to a vertex, you're going to have 14 triangles there, right? And the sum interior angles of a triangle is 180. So you're going to do 180 times the number of triangles presented, or after you drew the triangles of that particular polygon, right? So 14 times 180 Okay, 14 times 180, which is 2,520. That is the answer after you put it in the calculator. Okay? All right, let's move on. This right here, quadrilateral ABCD is an isosceles trapezoid. Okay, so that we can assume this is an isosceles trapezoid. So we can, I'm not going to go ahead and look at the questions. I'm just going to use the properties that I know about an isosceles trapezoid. Well, number one, the diagonals of an isosceles trapezoid are congruent. And then the base angles are congruent. So this angle here and this angle here are congruent, and then this angle here and this angle here are congruent. Now, please do not say that angle B and angle C are congruent. If we take a look, this one's a little smaller than this one, so don't say that those are congruent, but compare those two. They're consecutive. So this angle here and this angle here are congruent, and this angle here and that angle there is congruent. What else can we say? Well, since it's an isosceles trapezoid, well, a trapezoid, they have one pair of parallel sides. Okay, so I think that's all I need to do. Well, let me go ahead and mark the diagonals. This diagonal and that diagonal, they're congruent. So that's going to be that could be useful to mention. Which angle is congruent to angle BCD? So here's B to C to D. So which angle is congruent to BCD? Well, if we take a look, there's only two arcs here. So which of the following has two arcs? Well, angle ABD. So angle ABD, because it has two arcs. Which side is parallel to AB? So AB. Well, we have a marking here. We need to figure out which also has one marking there. And that's going to be DC, or segment DC. Which segment is congruent to AC? Well, AC is here, right? And again, the diagonals are congruent, so this should be segment BD. Okay? All right, let's go ahead and take a look at this. This is pretty much a repeat of what we just did. So for 7, I'm just going to put the answers. It's going to be, so to find the sum of the interior angles of a pentagon, that's going to be 540, and then a decagon, the sum of interior angles of a decagon should be 1,440. So you can go ahead and look at how you do the examples here. It's the same thing, but here. So one interior angle of a pentagon. Okay, so I'm only talking about one angle. I'm not talking about the whole angle here. If I want to find one interior angle of a pentagon, I basically take this formula and divide it by the number of sides. So it's going to be n minus 2 times 180 divided by n. Okay? So if I'm talking about a pentagon, remember pentagon is n equals 5, and a decagon is n equals 10, I can go ahead and figure that out, that one interior angle. So 5 minus 2 times 180 divided by 5, which is going to be 108. Okay, and then for a decagon, so it's 10 sides, that's going to be 10 minus 2 times 180 divided by 10, which is equal to 144. Okay, so respectively, a pentagon is 108 and a decagon is 144 in terms of one interior angle. One exterior angle, well, so this... Well, the sum of the exterior angles of any polygon is 360. So for a decagon, since it has... Well, let me go ahead and write the formula first. It's going to be 360 divided by n, okay? So for a decagon, all I have to do is 360 divide by the number of sides, which is 5. And, well, if I put that in the calculator, that's going to give me 72. So one exterior angle of a pentagon is 72. Let's go ahead and do the same thing for a decagon. Decagon, 360 divided by 10, that's just going to be 36, right? So one exterior angle of a decagon is 36. Okay, so now, last thing I want to go ahead and do is talk about the sum of the exterior angles. Well, it's non-negotiable. Both a decagon and a pentagon, or any polygon, is going to be 360 degrees. So for a pentagon, the sum of the exterior angles of a pentagon is 360. And for a decagon, that's the same case. The sum of the exterior angles of any polygon, specifically a decagon, is also 360 degrees. It's non-negotiable. Okay? All right. If QRST is a parallelogram, what is the value of x? Okay. Taking a look at this right now. So with a parallelogram, we know that the bisectors, or sorry, parallelograms, the diagonals bisect each other. And what it does, it creates a midpoint. So here, if I create a diagonal here and a diagonal here, and this is my parallelogram, it's going to create a midpoint, right? So if I'm looking at this diagonal specifically, well, here's the midpoint of that diagonal, meaning that we're going to have two even parts, two congruent parts to be exact. We're going to have one tick mark there and one tick mark there. And the fact that 12x minus x is this segment here and 14x minus 13 is... or 4x minus 34 is that segment here, they're congruent. I can just set them equal to each other. So 12x minus 8, which is equal to 14x minus 34. So that's going to be 26 is equal to 2x, and then 13 is equal to x. My answer is C. Okay, oops. My answer is C. Okay. The next thing I want to go ahead and do is if this is a kite, find each measure. So we're going to go and find GF. So here's GF, and then here's my kite. Notice that the diagonals of a kite, they are perpendicular. So if I draw a square there, well then I'm just going to figure out what GF is, right? So again, I do G. So since first of all, we have a right triangle, right? I'm going to draw my figure. So this is 4, 3, and that's a right triangle. I don't know what GF is. That's what I'm trying to find here. So this is a Pythagorean Theorem problem. So a squared plus b squared is equal to c squared. C, again, is the hypotenuse, right? What's across from the 90-degree angle? Well, this side here. So that's the question mark. So if I put it all together, I do 3 squared plus 4 squared, which is equal to my question mark squared. Take the square root on both sides. That's just going to give me 5 equals my question mark, which is GF, the desired segment I'm trying, or the trying to figure out the length of the GF. Okay, let's go ahead and do 13 now. Measure angle D. So this is a kite, and one thing that I want you to know about kites, the definition of a kite means that we have two pairs of consecutive sides. So this side here, that's one pair, and they're congruent, they're consecutive to each other, and then there's another pair here, and they're congruent to each other, and they are consecutive. So that's going to be good to know. The nose and the bottom, they are not congruent whatsoever. But the thing about a kite is that it has one pair of congruent angles. So that angle and that angle are congruent, and I think of this as like the wings, right? The wings, they have the same purpose. They function the same. Whereas a nose and the bottom, they're pretty much, not. They don't function the same whatsoever. Okay, so I'm trying to figure out what measure angle D is, right? And we know that angle D and angle G are congruent, so they should have the same number. I don't know what these are, so let's call this x, right? And if I call this x, and since this is congruent to G, this is also x as well, okay? So now I need to figure out how to, figure out what the value of those things are. How do I figure out what x is? Well, I need to set up my equation. Notice that this is a four-sided figure, so this is a quadrilateral. So then I can just go ahead and say, well, the sum interior angles of a quadrilateral is 360. So I do x plus 67 plus 49. So 2x plus 67 plus 49, which is equal to 360. That's just going to be, well, if I put everything together, x is equal to 122, which is measure angle D. This is my answer. Okay. All right. Quadrilateral N or MNOP is a rhombus. Find each value or measure. So measure angle MRN. So MRN. This is a rhombus. We can assume this is a rhombus because it's stated in the problem. What can you tell me with the diagonals? Well, they are going to be perpendicular, right? And if I'm talking about MRN, so here's MRN, that's going to create a 90-degree angle. So that's going to be 90, right? That dumb square is 90 degrees. 16, if measure angle PON is 124, so PON, that's 124. I'm talking about this whole thing here, 124. Find measure POM. Okay, so POM. Where's POM? POM. Okay, so if this whole thing is 124 and I'm trying to figure out what this angle here is, well, it's basically half of that, half of 124, right? So I do 124 divide by 2, which is 62. Okay, now if you have no idea what's going on, why am I dividing by 2? Well, this is a rhombus, right? The diagonals are going to split that full angle into 2 congruent parts. So this angle and this angle are congruent, and this angle and that angle is also congruent. So if this whole thing is 124, I just got to split it up into 2 congruent parts. Okay? Alrighty. I will see you in the next one.